This is Chemistry Made Simple YouTube channel. I take this opportunity to once again welcome you to this great learning platform. And hey, if this is your very first time, then you will never regret your presence here. Now, over the past month, we have been looking at the whole concept of organic nomenclature. Today, we still continue with the same concept, but now we look at the specific nomenclature of a class of organic compounds, generally known as aromatic compounds. First things first, what is the meaning of the word aromatic compounds? A simple explanation is that aromatic compounds are organic compounds that bear at least a benzene ring. Displayed besides me is the structure of a benzene ring. Now, if it happens to you that you come across any organic compound that bears the structure displayed besides me, then you are free to classify it as an aromatic compound. Henceforth, our nomenclature will be subdivided into three parts. In the first part, we shall try to have an insight into the nomenclature of monosubstituted benzene. In the second part, we shall have an insight in the nomenclature of disubstituted benzene. And finally, in the last part, we shall have an insight into benzene that has more than two substituents. Ladies and gentlemen, welcome to the first part, part 1, nomenclature of monosubstituted benzene. First and foremost, what does it imply by monosubstituted benzene? Monosubstituted benzene simply refers to a benzene ring that has one substituent along its carbon chain. Now, the common substituents that are always present on the benzene ring have been displayed besides here and their respective IUPAC names. Let me give you some time to gaze at them. With this now, we therefore dive into the specifics of IUPAC nomenclature of monosubstituted benzene. According to IUPAC, naming monosubstituted benzene will have two parts. That is, the first part is the IUPAC name of the substituent followed by the word benzene. To illustrate this, the displayed compound there is therefore, according to IUPAC, named as fluorobenzene. The next displayed compound there, also based on IUPAC, is methylbenzene. And finally, the next compound displayed there is nitrobenzene according to IUPAC. Specific consideration is rendered to alkyl substituents attached to the benzene ring whose carbon chain is longer than benzene ring. By this I mean having more than 6 carbon atoms, like in the example there. Now, to name such a compound mandates that the benzene ring is treated as a substituent, and according to IUPAC, the specific name of a benzene substituent is phenyl, and therefore the name of this compound becomes 2-phenylheptane. Finally, some trivial names of monosubstituted derivatives of benzene are also accepted by IUPAC, and these include the following. Number 1, displayed there, is benzoic acid. Number 2, displayed there, is toluene. Number 3, displayed there, is phenol. Number 4, displayed there, is aniline. Number 5, displayed there, is anisole. Number 6, displayed there is acetophenone. Number 7, displayed there is benzene carbaldehyde. Number 8, displayed there is benzene sulfonic acid. With this being said, I therefore welcome you to the second part, where we shall be looking at nomenclature of disubstituted benzene. Ladies and gentlemen, what is disubstituted benzene? Disubstituted benzene is benzene that has two substituents. Two systems can be used to name disubstituted benzene. In the first system, according to IUPAC, is that first and foremost, we must identify which of the two substituents is the principal or superior substituent. The list displayed beside me here is arranged in order of superiority. Of course, the highest in the list is the most superior, and the lowest on the list is the least superior. So therefore, we shall first choose the most superior group, and the most superior group together with benzene give us the parent name of the compound. The second guideline is that we assign numbers to the disubstituted benzene such that the other substituent occupies a less position. And mind you, when we are numbering the benzene ring, it can be clockwise or anti-clockwise. And after this, we therefore write the name of the whole compound. To illustrate these two rules or guidelines, there are some examples. The first example there, the benzene ring has two substituents, that is the carboxylic group and the amino group. Now, according to the list that we displayed, the most superior group is the carboxylic group, and therefore the parent name of this compound is benzoic acid. Now, assigning numbers to carbon atoms of the benzene ring, starting from the carbon atom attached to the carboxylic group, we identify that the amino group is on position 4. And finally, we now write the name as 4-amino benzoic acid. Second example we have here displayed is that on the benzene ring still there are two substituents. The first substituent is a methyl group, and the second substituent is a chloride group. Now, according to our list, is that the chloride group is of less superiority. So the most superior group is the methyl group, and this therefore mandates that our parent name is toluene. Now, by assigning numbers to carbon atoms of the benzene ring, starting from where our methyl substituent is, we find out that the chloride group is attached to position 3. And after this, we therefore write the name of the compound as 3-chlorotoluene. Our final illustration here is the example displayed there, where the benzene ring has two groups, that is the hydroxide group and the nitro group. Now, notice that the most superior group, if you were to compare the two, is the hydroxide group. And this mandates that the parent name of this compound is phenol. By assigning numbers to carbon atoms of the benzene ring, starting from where the hydroxide group is attached, we establish that the nitro group is on the second carbon atom, and therefore the name of this compound is 2-nitrophenol. So that is the first system according to IUPAC. The second system that can also be used to name disubstituted benzene is by using the positions ortho, meta, and para. First and foremost, we need to understand what it means by ortho, meta, and therefore para. Now, after identifying the highest priority group on the benzene ring for disubstituted benzene, the second carbon atom is known as the ortho position. The third carbon atom is known as the meta position, and the fourth position is known as the para position. So without wasting time, therefore, the examples we have displayed here, example 1, to illustrate this, the most priority group displayed on this compound is the carboxylic group, and the other substituent is the amino group. Now, by taking into consideration ortho, meta, and para position, we find out that the amino group is actually on the para position, and therefore the name of this compound becomes para-amino benzoic acid. The second example here has two substituents, that's the methyl group and the chloride group. Notice that the methyl group is the superior group, and therefore the parent name is toluene, but the chloride group has been attached to position 3 and is on the meta position, and we can therefore write the name of this benzene compound as meta-chlorotoluene. Our final example is that we are having still two substituents, that is the hydroxyl group and the nitro group. The hydroxyl group is the most superior, meaning that the parent name of this compound is phenol, and by referring to ortho, para, and meta positions, is that the nitro group is on the ortho position, and therefore the name of this compound here is ortho nitrophenol. Finally, it is possible that you can also have two similar substituents. In this case, just number the carbon atoms of the benzene ring such that the locants of the substituents gives you the lowest sum. The first example displayed to illustrate this, besides me there, is that we are having two substituents. There is a chloride substituent and a bromide substituent. By numbering in the clockwise direction, the bromide substituent is on the first position and the chloride substituent is on the third position. We therefore write the name of this compound by basing on alphabetical arrangement of the two substituents as 1-bromo-3-chlorobenzene. Second example to illustrate this also is that we are having a benzene ring that has two methyl substituents. The methyl substituents are situated on the first carbon atom and on the fourth carbon atom. So how do we name that one? It becomes 1,4-dimethylbenzene. Notice that this specific compound in example 2 here can also be named as 1,4-xylene. So with this, we come to the end of the second part, and we therefore go to the last part, or part 3. In part 3, we shall be looking at how to name benzene that has more than 2 substituents. Well, according to IUPAC, to name benzene that has more than 2 substituents, that means it can be 3, it can be 4, 5, up to 6, is that first and foremost, we identify the high priority substituent. Remember our list of priority. So after identifying the priority substituent, we assign numbers to carbon atoms of the benzene ring in a clockwise or anti-clockwise direction, such that the other substituents give you the lowest locant sum. And after this, we are therefore able to write the name of such a compound. Examples to illustrate this. The first example there displayed has 3 groups. The first group is the hydroxyl group, the second group is the methyl group, and the third group is the bromide group. Now, of course, the priority group is the hydroxyl group, and therefore the parent name is phenol. Now, the methyl and the bromide group have been attached on position 3 and position 4 according to the correct numbering. By considering the alphabetical superiority of the two groups, the name of this compound is therefore going to be 4-bromo-3-methyl-phenol. Our final example here displayed is that we do have a benzene ring whose substituents are the amino group and 3 other chloride groups. Now, of course, referring to our previous list is that the amino group is the most superior, and therefore the parent name of this becomes aniline. Now, the 3 chloride atoms have been attached to carbon atoms number 2, number 3, and number 4. And therefore, the name of this compound is going to be 2, 3, 4 hyphen trichloroaniline. With this being stated, I think the nomenclature of benzene is no longer very difficult for you. I now take this opportunity to welcome you to our classroom. And in our classroom, we have physical examples that have been written, and we are going to name them. Ladies and gentlemen, this is the classroom. Before us, we have 2 compounds that we are supposed to name by basing on all the procedures that we have studied in part 1, part 2, and part 3 above. First and foremost, observe the groups that have been attached to our benzene ring here, and you'll find out that this here is the most superior. And because this is the most superior, it therefore mandates that the parent name is toluene. After determining the parent name, the next procedure mandates that we must assign numbers to the carbon atoms on the benzene ring, starting from the most superior substituent. So this becomes therefore number 1, this is number 2, number 3, number 4, number 5, and number 6. Now this is in the clockwise direction. In the anti-clockwise direction, so this is number 1, number 2, number 3, number 4, number 5, and number 6. So therefore, you have to identify that in the clockwise direction, you have a substituent on position 2, position 4, and position 6. In the anti-clockwise direction, you have substituent on position 2, position 4, and position 6. Now, on analyzing the numbers 2, 4, and 6, you realize that either clockwise or anti-clockwise for this specific compound, you will have substituents on the same positions. However, if there were different positions, then the correct choice would have therefore been the position that gives us the lowest locant sum. So at this point, we can now write the name of our compound as follows. Is that on position 2, comma, position 4, comma, and position 6, we have 3 similar groups. And because they are 3, we use the prefix tri followed by the name of the substituent. The substituent is a nitro group. And then finally, the parent name. So, therefore, the name of our compound here in part A is 2,4,6 hyphen trinitrotoluene. This compound is commercially known as TNT and is used as an explosive. After this, we move on to our second compound here in part B. Is that first and foremost, this compound can be treated as an aromatic compound. Why? Because it has a benzene ring, but also it has an aliphatic chain. So we have to first and foremost identify whether we are going to name it either as an aromatic compound or by basing on rules of nomenclature of aliphatic compounds. Now, according to the guidelines above, we are not going to name it as an aromatic compound. And why? This is because the substituent that is attached to it is taking the parent name or is the parent chain. Why is this substituent the parent chain? It is because according to rules of IUPAC nomenclature, the parent chain is also the longest carbon-carbon chain that has the highest number of substituents. Realize that, well, this has 6 carbon atoms and also our benzene ring has 6 carbon atoms, but on our benzene ring there's only one substituent, while on this other chain there are 1, 2, 3 together with benzene 4 substituents. So therefore this becomes our parent chain. And without wasting time, we assign numbers to our parent chain. So we can assign numbers from here. So that is 1, this is 2, 3, 4, 5, 6. And we also assign backwards 1, 2, 3, 4, 5, and finally 6. Now, according to our other procedures that we have studied in subsequent nomenclature concepts, is that we are interested in the number 1, number 2, number 3, number 5, and also we are interested in the number 2, number 4, number 5, and number 6. So we pick out those numbers and compute their sums. So we shall have 1 plus 2 plus 3 plus 5. This is from that side going that side, and also coming this side we shall have 2 plus 4 plus 5 and finally plus 6. That is coming this side. Of course, the sum of this gives us 11 and the sum of this gives us 17. Now, Of course, the rules say that we are supposed to choose the lowest sum. So we are therefore going to name this compound by basing on these positions here. So we now start naming our compound. How do we name our compound? Is that we have to remember that there are three different groups, and therefore the three different groups must be written in order of alphabetical superiority. So this is a methyl group, this is a chloride group, and this is a phenyl group. Therefore, by basing on the alphabetical superiority of the three different substituents, we write the name of this compound as follows. So the first one is 2,5. These are two of them. And then on position 3, we have our methyl group. And then on position 6, we do have the phenyl group. And finally, the parent name. The parent name is a 6-carbon alkane whose name is hexane. As simple as that. Ladies and gentlemen, I want to take this opportunity to once again thank you for being part of this. I hope that the naming of benzene is now clear to you.